Okay, so the second part of these class notes are chapter 10.1. So property of equality, if two bases are the same, then you could say the exponents are also the same by logic. So if you had b to the 2 equals b to the x, hopefully it doesn't take too long to figure out that x equals 2. So to solve exponential equations like the one below, we change each side of the equation to have the same base. So to be able to use this property, we need the same base. And here are some tips. Sometimes it helps to change the bigger base to be the smaller base. So if you had to choose between 2 and 16, you want to change 16. It's bigger. However, when you have a fraction, you use the negative exponent property. So for instance, if you had 1/2, you can change that to 2 to the negative 1 to make it a bigger base. So for 16, write 16 with a base of 2. 16 is the same as 2 with a certain exponent. And 2 to the what is 16. And see if you could write the next one, and I'll pause the video. The next one, you have a fractional base. So 127 with a base of 3. If it were just 27, that would be 3 to the third. But if it's a fraction, it would be 3 to the negative third. And pause this video and see if you could do the next one. So that's the answer. 1/16 equals 2 to the negative 4. And this is the idea that we use to solve the following equations. So on the first one, you see a 2 and a 128. You want to change the bigger number, 128, to be a base of 2. So we'll rewrite the first, or the left side, and it equals 2, and 2 to the what is 128. And it's 2 to the 7th. 2 to the 7th is 128. So once the bases are the same, you can ignore the bases, and you set the exponents equal to each other. And then it's a pretty easy equation to solve. You get 3x equals 2, x is 2/3. X is 2/3. See if you could do the next one. If you'd like to pause this video, see if you could write 100 with a base of 10 and solve. So when you write 100, you write it as 10 squared, and be careful to write parentheses around the exponent that's already up there. And then you can have x minus 1 equals, distribute the 2, 4x minus 6. Subtract x, add 6. So you get x equals 5/3 would be your answer. For the next one, 1/16 is a fraction, so you want to change that. You'd have 2 to the 2n is less than or equal to 1/16 would be 2 to match the base of the other two. 2 to the what? It's a fraction, so we need a negative. And 16 compared to 2, 2 to the 4th is 16, so you need a 4. And once those are the same, you have 2n is less than or equal to negative 4, so n is less than or equal to negative 2. On the next one, between 1/7 and 343, 1/7 and 343. So you have to change both sides. So why don't you take a minute, pause the video, and think about how you can change 1/7 and 343 to have the same base. So we have 1/7 is 7 to the negative 1, and then we have 343 is 7 to the third. So then you can have negative y plus 3 equals 3, negative y equals 0, so y equals 0 is the answer. Why don't you pause the video and see if you could answer the next question, and you have to change both sides. So we have 9 is 3 squared, so we'll substitute 3 squared in, and 27 is 3 cubed, so we substitute 3 cubed in. So we have 4x plus 2 equals 3x, and you can subtract 3x from both sides, subtract 2 from both sides, so you get x equals negative 2. And the last one, I'll show you the answer, so pause the video and see if you can do this one entirely. There's a couple different ways that you could do it. So if you change the 1/81st to 1/3, it would be 1/3 to the 4th. You could change both sides to a base of 3, and you'd have 3 to the negative 1, and 1 over 81 is 3 to the negative 4. But from here you'd have n minus 2 is less than 4n. You would subtract n from both sides, 3n. So that would be n is greater than negative 2 over 3. And that's your answer. And thus concludes the lesson recording.